throughout chapter 1, we've done some graphing of linear equations. We talked about slope last week of what that would look like and how to find slope of a linear equation. Today we're going to talk about how to write a linear equation. And we're going to, once again, review the two different types of equations that we typically will write in that form. Once again, the two that we have to know how to write are slope-intercept. And I would say this would be the most common way of writing an equation. This would be our go-to equation. If it said write a linear equation, then slope-intercept form is the one we almost always go to. But there will be times where either we're given an equation and standard form, or we have to write an equation and standard form, and that is your ax plus by equals c. Obviously, this one has a lot of advantages to it because if I know the slope and I know the y-intercept, then I'm ready to go. We know that m always represents slope. We know that b always represents the y-intercept. Those are things that we've talked about several times already in the first couple of weeks. Standard form doesn't have a whole lot of good pieces to it, right? It's really the a, b, and c values are going to be numbers, integers, usually not fractions or decimals, but they don't represent anything. They're not your slope, they're not your y-intercept, they're just going to be numbers in an equation. So what's going to happen today is they're going to give us different situations, different scenarios, and we have to write an equation based off the information they give us, okay? Some of them are going to be a piece of cake. Some of them are going to be a little bit more work than others. So if I start off with one that's a little bit easier. The directions, and I'm not going to write this down every single time today, but just know the directions in your problems today mostly are going to say, and we'll talk about some other ones here in a little bit, but at the beginning of the lesson especially, it'll say write a linear equation using the given information or something along those lines. So in this case, we have the slope, -7/9. We have a point, 0, 12, okay? But not only is that point, what else could we say about the point 0, 12? What's something special there? It's the y-intercept, right? So they won't necessarily just come right out and say, hey, here's our y-intercept, but we know it's the y-intercept because it's 12 up on the y-axis, right? And so we could even take it one step further and we could say my b value is 12, even though they didn't tell me that to begin with. And if they say write a linear equation, I'm always just going to go into slope-intercept form unless they tell me differently. Unless they say write the equation in standard form, I'm not going to go that far. Okay? I'm going to always go to slope-intercept form unless otherwise stated. All we got to do is plug in for m and b, and it's as easy as that. So I told you some are going to be easier, some are going to be harder. That's kind of more on the easier side of things, obviously. Okay, on the next one, I'm going to show you two different methods here, okay? And obviously you don't have to do both methods, but only reason I show you this is because I feel like at some point in time you probably learned both of these methods and you might still like one versus the other. I probably am going to prefer the one that only uses slope-intercept form, but I'm going to show you another one because you maybe have seen that before. Okay, so this will be the only problem today that I'm going to show you two methods. Okay, method 1 is only using slope-intercept form. The other reason why this one's a little bit different than the one we did just a second ago is it is a point, but this point is not on the y-axis, right? It's just a random point. I go left 3 and up 6 if I were to graph it. It's just sitting out there in one of the quadrants, okay? And it really doesn't matter what quadrant it's in, but I want to write an equation. If I were to plot that point and then plot the slope from that point, what would be an equation of that line? We don't necessarily have to do the graphing of it, even though we've done that earlier in the chapter, but just kind of visualize what it would look like and what that line would look like. Now we're writing an equation for that line. So here's what we're going to do. My slope is negative 2 over 3. The point, negative 3, 6, is an ordered pair, and we know that all ordered pairs are x and y. So we have 3 pieces of information. We have m, we have x, and we have y. The only thing that I don't know in this equation is b. But we got to have b. We got to know what b is. But I don't have a number just to plug in for b, like I did on that first problem. So we're going to just plug everything in one at a time here. My y value is 6. Slope is negative 2/3 times negative 3 plus b. And we're going to solve for b, that y-intercept. Hey, this might be something like, oh, I'm just going to use my calculator for this, but I'm going to tell you, you should be able to do this in your head pretty easily. And you might say, whoa, there's a fraction. How do I do this in my head? Okay, it's not a big deal at all. Negative 2 times negative 3 would be 6. 6 divided by 3 is 2. Okay, so if I multiply negative 2/3 times negative 3, that becomes 2. And we can do that pretty quickly. Okay. Now, sometimes it's not always going to be a nice whole number, but that's okay. In this case, it is. And then we can subtract 2 from both sides, and I get b equals 4. So when I finish out my equation here, we're always going to finish in slope-intercept form. That's our equation. Okay, that's one way to get there. And that's probably the way that I prefer, and I'm kind of guessing that that's the way that most of you are going to prefer after seeing the second method. They're both about the same length, so it's not necessarily one's a lot harder than the other. The only reason why I don't necessarily like method 2 is because it's using a formula that we don't use very often. You might remember from way back, we had a third form of an equation that we called point-slope form. And because we've seen this before, I'm just using this and showing you how to do this. But it would make you memorize or know a third form of an equation. But one of the reasons why I show this to you is because the name point-slope means if I have a point and I have a slope, I can write an equation in that form. And that's what's that?
Is the first y y1 or this y2?
This one here?
Yeah.
Just y.
Just y.
Yep, y minus y1. And I'll show what that all means here in just a second. Okay, if we go off the name point slope, we have a point, an ordered pair, we have a slope. So a lot of people will say, oh, hey, we got point and a slope, so I'm going to use point slope. And so that's why it's not wrong. It's just another way of doing it. When I look at the 2 pieces of information that we have, here's where it's going to be a little bit different. And I think that kind of goes to Lane's question too, is the ordered pair here, instead of calling it xy, we're going to call it x1, y1. Kind of like we did last week when we did distance formula and midpoint formula and all of that. We labeled the first ordered pair x1, y1. So when I put this into my equation, we are not going to put anything in for this y or this x. They're just going to stay y and x. Okay? Every equation is going to have an x and a y in it. So when I write this one out, we're going to go y minus y1, which is 6, equals my slope times x minus x1. So x minus negative 3 would really be x plus 3. Okay, and if I'm writing an equation in point slope form, I would be done. And so there might have been some times in years past where this is the way I wrote my equation. But in college algebra, we don't ever hardly leave equations in point slope form. Okay, so what I want to do is I want to transform this into y equals mx plus b. That's our go-to form. Well, if I wanted to change this into y equals mx plus b, what would be the first thing I would need to do? Distribute. Yep. If I got parentheses, I got to distribute through those parentheses. So the y minus 6 stays. If I take negative 2/3 times x, it stays negative 2/3 x. If I take negative 2/3 times 3, negative 2 times 3 is negative 6. Negative 6 divided by 3 would be negative 2. Or you could simply just say those 3's are just going to knock each other out. And then the last thing we would do to get y by itself is we would add 6. And if you notice, we get the same thing either way. Okay. And I'll just say this is probably the way I would prefer, because you're using slope-intercept form over and over again. If you did it this way, I'm totally fine with it, but I'm probably not going to show point-slope form very much at all. That might even be the only time all semester that I show you any point-slope form, just because we very rarely use it in college algebra. But if I had to ask you guys, is there anybody in here that, and you can say it if so, is there anybody that would prefer point slope form as opposed to slope intercept form? Do you guys even remember doing point slope form? Does that even look familiar to you? Not really? Okay, so maybe that's maybe not even something I need to show moving forward, but it is another option out there. Okay, another way that they could give me information. Okay, the first couple of examples that we did, we had a slope and we had a point. This time, we have 2 points. We have 2 ordered pairs. Okay, so we really don't have any information. Neither one of the points are my y-intercept. These are both just points sitting in a quadrant somewhere. If I was going to graph it, I would graph them both, connect with a line, and make my line, and then I would write an equation for it. Okay, so the first thing I would need to do here is find the slope. And this is something we talked about last week. So here's where that slope comes into play. I probably wouldn't graph it and then try to find the slope off the graph unless it was already graphed, but it probably won't be. It's just going to give you that information. Especially if I don't have a piece of graph paper, that's probably not even on the table. But probably the slope the slope formula would be the best way to go here. And so what we said last week was label the points x1, y1, x2, y2. Doesn't matter which one's which. They could be interchangeable. You could call this one x1, y1 if you wanted to. And we're going to plug it into the formula. Negative 4 minus 3 over 1 minus 2. So negative 7 over negative 1 becomes 7. Okay, just simplifying our numbers. Because I have 2 points given to me at the beginning, now I can choose which one of those points I want to use. So if I had to choose between 2, 3 and 1, negative 4, which one would be better?
2, 3.
Yeah, 2, 3. I would always choose the one that doesn't have negatives. Negatives are another thing that could throw off our problem or work that we're doing. So I would always prefer positives if I had to choose. So I'm going to use the slope of 7. I'm going to use the point 2, 3. If you used 1, negative 4, you're going to get the same answer. Okay? So it doesn't matter which one you use, but I'm going to try to pick the easier of the two. Once again, we're going into y equals mx plus b. This is x, this is y, and we're going to write the equation out. 3 is y, m is 7, x is 2, plus b. And then we subtract 14 from both sides. And we get b equals -11. Okay, and the last thing we always do is finish up with our equation. 7x minus 11. Okay. So, some people might say, well, wouldn't we say, since it was y equals mx plus b, wouldn't we write 7x plus -11? There's no reason to write plus -11. It's easier just to say minus 11. Okay. It's not necessarily wrong if you say plus and -11, but one sign's enough in that case. If you had minus and negative, we always make that a positive, but we don't need to do plus and negative. Okay, all of those are very, very similar to one another. The only difference is what was given to us at the beginning to start with. Okay, the next couple equations that we're going to work through, we're going to write an equation of a vertical line that goes through the ordered pair 7, 3. Okay, and this was kind of one of those exceptions to the rule because it's a special equation. If we talk about a vertical line, what's my slope?
0. Isn't it just undefined?
Undefined. Yep, vertical line is always undefined, okay? Always undefined. So if I have a vertical line, the slope is undefined. So what makes this kind of weird is now we have an undefined slope. It's not a number, it's not a fraction, it's just undefined, right? And we kind of talked about this briefly last week as well. And I kind of showed you some things you kind of think about. If I have the point 7, 3 sitting out there in space, and I have a vertical line that goes through that point, that's what we're talking about, right? And just getting a visual of what's going on here, this line crosses the x-axis at 7. And so my equation here is x equals 7. Okay. We kind of talked about it last week. If I have a vertical line, it's always got an undefined slope, and the equation always looks like this, x equals 7. It only crosses the x-axis, and in this case, it crosses it at 7. We can't write y equals undefined x plus whatever, right? Number one, there's no y-intercept. Number two, there's no slope, okay? So we can't use slope-intercept form here. This is the way we have to write the equation. It's still a linear equation, it just happens to be a vertical line, okay? I could do the same thing for a horizontal line. If I wanted to write an equation of a horizontal line, that goes through the order pair 1, -6. If I have a horizontal line, the slope is always 0. And you don't always have to draw yourself a picture, but I think sometimes drawing yourself a picture could be helpful. And the reason I like drawing the picture is, I mean, and you can kind of visualize it the same way. It only crosses the y-axis, and it crosses it at -6. Okay, and so could I write my equation like this? Y equals 0x minus 6? Theoretically, yes, but do I really need the 0x in there? Probably not. So when we write a horizontal line, we always say y equals -6. Okay, so vertical lines are always x equals, horizontal lines are always y equals. There's not a whole lot of work to go through, okay? All you have to do is recognize vertical, the x equals whatever the x value is. If it's horizontal, it's always y equals whatever the y equals value is, okay? So x equals 7 for a vertical line, y equals -6 for a horizontal line. Okay? There's not you don't have to really show any work at all on something like that. Okay, the other thing that we're going to throw into the mix here are parallel lines and perpendicular lines. So when we talk about linear equations, we have lines, and those lines can intersect one another, or in this case, they could be parallel to each other. And so we're comparing two different lines, essentially, okay? If two lines are parallel, we know what that looks like. I mean, that kind of goes back to our good old geometry days, right? Two lines that keep going that never intersect. We could do it on a coordinate plane, but it doesn't necessarily have to be a coordinate plane, but in algebra, typically it is a coordinate plane. Okay, two lines that never intersect one another. What would be the dead giveaway if I look at an equation, or two equations for that matter? How would I know that they are parallel?
They have the same slope.
They have the same slope, okay? Parallel lines have the same slope. And so that's how, if I can look at an equation, you're gonna have a couple of questions today where it's gonna ask you, what type of lines are these? Are they parallel or are they perpendicular? And in some cases, you'll even say neither. They're not parallel or perpendicular. And we'll talk about what that means here in just a second, okay? But if they have the same slope, they are parallel. They will never intersect one another. Okay, perpendicular lines are two lines that intersect, but not only do they intersect, but what do they form when they intersect? Okay, they make an X, but what do we have right here? 90-degree angle. Okay, they intersect at a right angle. And I'm not going to ask you to get out your protractor and measure that angle. There's some things that we know about those two lines that we will know that they are perpendicular without even knowing that the 90-degree angle is there. Okay, but that is the definition of perpendicular, is the two lines that intersect at a 90-degree angle. Okay, some things that we're going to look for here. If one of the lines has a slope of (4 over 3), then what would the line perpendicular to that first equation be? What would be the slope of? Close. -3 over 4. Okay. So we are going to flip it, and we're going to switch the sign. So I have a little saying that I say here. I always say, to get the other slope, we are going to flip the switch. We're going to flip it over, and we're going to switch the sign. If I had a number over here like 6, then this would be -1 over 6. We're going to think of 6 as 6 over 1, and we're going to flip it to be 1 over 6. The algebraic or the math terminology there is we say that they are opposite reciprocals. Opposites means one's positive, one's negative. Reciprocals means we take the fraction and we flip it over. Okay, so those will always be true with perpendicular lines. Okay, so knowing that information is going to be critical with some of the things that we're going to be doing with parallel and perpendicular today. Okay, one of the types of questions that they're going to give you is they're going to ask you to identify if two lines are parallel, perpendicular, or neither. Okay, so we just kind of walk through the steps. Do they have the same slope? If so, we know they're parallel. Okay? If they don't have the same slope, are their slopes opposite reciprocals? If neither one of those are true, then we would say neither. Okay? And what that would look like is a neither situation would look something like that. Okay? The two lines are crossing, but they're not crossing at a 90-degree angle, and they're definitely not parallel. Okay? Not that you have to graph it, but some people ask me, what does neither look like? And it would look something like that. Hey, Chloe. All right, so first up, I'm going to give you a couple of equations here. Okay, as I look at these two equations, do I know what the slope is right now? No. Okay. Neither one of them are in slope-intercept form. So I don't know what the slope is immediately. If both of them are in slope-intercept form, I could just look at the equation and say, yep, there it is. I got the slope and I know what the slope is. Now let's compare the two. So in order to be able to find the slope here, there's a couple of things that we could do. The first thing we could do is we could put it in slope-intercept form. So for the first equation, that would mean subtracting 2. Now it's in slope-intercept form, and my slope is 5. For the second one, this one, and here's where standard form is going to kind of come into play. I told you we wouldn't see it a lot today. It's not necessarily our equation of choice, but we will see it on problems like this, where we have ax plus by equals c. And when we did slope the other day, we talked about the shortcut. So here's another reason or place where that shortcut can come into play. In standard form, we have an a, b, and a c value. And this is kind of our shortcut. Now, could I solve for y like I did over here? Yeah, but I think that takes a little bit more time. You've got a couple of steps that you got to do to get there. The shortcut, all I got to do is the opposite of 1 over 5. And that's my slope. But you just got to remember what the shortcut is. And then we're going to compare the two. This one has a slope of 5. This one has a slope of negative 1 over 5. So are they the same? No. So they're not parallel. Okay. Are they opposite reciprocals?
Yes.
Yeah. Okay. So here we would say these two are perpendicular. If they're not parallel and they're not perpendicular, we would say neither. Okay, let's do one more like that. Okay, on this one here, I give it to you like this because you're going to see sometimes they give you an equation that tries to throw you off a little bit. Okay, both of these are in standard form, so it's not much different than what we did just up here. But when it's in standard form, x always has to be first, right? In this case, x is not first. So if I was going to do the opposite of a over b, this is actually my a value. This is my b value. The a value is always what's in front of the x. The b value is what's in front of y. Okay, same thing over here. This would be my a value. This would be my b value. Then you could do the opposite of a over b. I don't really care about this number over here. We're not using that number over here. It's my c value, but we don't need to worry about it. So this one would be negative 4 over 2, which is negative 2. This one here is opposite of a over b, negative 2 over 5. Okay, are these two parallel? Definitely not the same. Are they perpendicular? No. So here we would say neither. Just got to find the slope. Slope tells us everything.
Are we allowed to change 4 over 2 to this negative 2?
Yeah. Yeah.
Oh, I didn't see that.
Yeah, you're good. Probably would rather you do that too. Yeah. Okay, the last thing that we're going to do here, okay, I'm going to give you an equation. And we're going to do two things with this equation. We're going to write an equation parallel to the original and goes through the point 6, 12. Hey, first thing I always want to do, okay? Here's my original equation. This is the equation that they are providing or giving me. I want to look at that and I want to determine what is the slope of this original equation. Well, we're in standard form again, right? So I can't just look at it and say what's my slope, but I can say opposite of a over b, which would be negative 1/2. So my slope is negative 1 over 2. My point would be 6, 12. And we would go through all of the work like we did a little bit ago. Okay? Because we're running out of time here, I'm not going to go through all the work for that, but this would be your m, your x, and your y. You plug it into y equals mx plus b, find your b, write your equation. Okay? Everybody good with that? Okay, over here, we would have the same instructions, but instead of parallel, it's going to say perpendicular to the original and goes through some given point. Let's say negative 2, 0. So here, my perpendicular slope, what would be perpendicular to negative 1/2? 2 over 1, okay? 2 over 1, and we could just write it as 2, because we're going to flip it, and we're going to make it opposite. So if this is negative, this has to be positive, okay? So we would use 2 as our slope, we would use negative 2, 0 as our point, and we would write it out using y equals mx plus b, okay? So the rest of the steps are things like we did earlier in the lesson, but just the way the question is worded is a little different. All right, here we go. Assignment for today. All of our assignments are due on Wednesday. If you have them done tomorrow and want to check your assignments off tomorrow, I can do it tomorrow. If not, Wednesday is the due date. And remember, it's just a completion more than anything else. Number 61, we have to use a calculator. So tomorrow I will start off with that one at the beginning of the hour, show you how to do that one. If you're not sure how to do that one, we'll go through that one together. I hoped to be able to get through that a little bit today, but we will remind me tomorrow and we'll start with that one tomorrow.
my throat hurt really
I
bad.
don't think there's anything else.
But she was like, oh, you're not staying.
Yeah, I mean,
Okay, see you guys. Have a great day.